knows how long, where any old spores can fall on it, hands have been touching it, maybe we're breathing on it, who knows what else. This is the lowest degree of sterility, which I call unsanitized. Now, I'll wipe it thoroughly with isopropyl alcohol using sanitized gloves and place it into my sterile workspace. However, remember that sanitizing something with alcohol does not necessarily sterilize it. Because we cannot know with certainty that the outside of the petri dish is completely sterile, we have to assume that it's not. This is the second degree of sterility, which I call sanitized. Now, this petri dish came in a plastic sleeve that was pre-sterilized at the factory using ethylene oxide gas. It was opened in front of a laminar flow hood using sterile culture technique, and only so briefly opened, filled with sterilized agar media, and then sealed with parafilm. Now, there's always a tiny chance that there is some problem in some part of that process. But we're as sure as we can be that the inside of that petri dish is completely sterile. This is the highest degree of sterility, which I call sterilized. Now, as I'm about to describe in detail, we always start by completely sanitizing our entire workspace. Then, everything that enters that workspace is also separately sanitized. Each tool, your gloves, every petri dish, every jar should be wiped with alcohol before placing it into your sterile workspace. If something which has been sanitized leaves the sterile workspace or comes in contact, touches something that's not sanitized, it needs to be re-sanitized with alcohol before returning it to the sterile workspace. If you touch your hair, press pause on your phone, or pick up an unsanitized jar, you should also re-sanitize your gloves before moving on. Something which has been sterilized should never come in contact with anything else that has not also been sterilized. For example, if you wipe off your scalpel blade with an alcohol-soaked paper towel, yes, it's sanitized, but it should be re-sterilized before its next use. Likewise, if you drop an agar wedge on your work surface, that work surface has been sanitized, but you should assume that that wedge is no longer sterile and avoid using it, unless of course you're just curious to see what happens. Now, all of this might seem like overkill, and perhaps it is, but it's important to think about the fact that if there's even a chance that something is no longer sterile, it's usually still less work to stop, go back, re-sterilize, and redo everything from the beginning than to grow it out, hope that it works, find out that it didn't, run into contamination, and have to redo the whole process later on anyway. Plus, it'll help you avoid running into problems that will discourage you from wanting to continue working on this process altogether. Anytime I get ready to do sterile culture work, I always make a mental tally of the degrees of sterility of each item in my workspace, and I arrange them in accordance of the order of their priority of sterility, as I like to say. The main idea here is that nothing should ever be upwind or above something of a higher priority of sterility. If you're using a laminar flow hood, the things with the highest degree of sterility should be upwind closest to the filter, like sterilized petri dishes or your sterilized grain spawn. And the objects with the lowest degree of sterility, such as your body, you filthy primate, should definitely be farthest downwind and behind any of the other more sensitive work. If you're just using an alcohol lamp, this means you want to position the objects with the highest priority of sterility, things like petri dishes. You need to keep sterile as close as possible to that alcohol flame. And it's also good to keep them a little bit further away from your body so you're not tempted to reach over them towards something else. Which brings me to my next point. So, anytime you're working with open jars or exposed petri dishes, it's important to be especially mindful of the position of your hands or your tools and do your best to stay out of the no-fly zone. As a side note, the lab is also a no-fly zone. Flies can ruin sterile culture work faster than anything, so despite being a pacifist, if one gets into my lab, I go full Walter White and make sure to take care of that thing before anything else happens. I find that a firm blast from the isopropyl bottle will usually knock the bugger out of the sky, where the merciless boot can deliver the fatal blow. Of course, it's impossible to be perfect. Even if your technique is flawless, there are always factors that are outside of your control. Even if the flow hood itself is 99.999% effective, there's still a statistical inevitability that at some point something is going to get through. This is why we not only want to sanitize or sterilize everything that goes into our sterile workspace, we also want to work quickly to minimize possible exposure time. I have a system I like to use for tracking this, and I call it green, yellow, red light. When setting up the workspace and sanitizing everything, all of the jars are sealed, the petri dishes are all sealed with parafilm, and everything is totally safe and nothing can get in. While this is happening, I've got a green light on in my head. And the moment that I peel off some parafilm or loosen a jar lid, that light changes to yellow. Everything is still covered, but the tasks become more sensitive and more focus and care is required. I don't talk, whistle, or sing, and I don't take my attention off of what I'm doing. I don't want to hang out in the yellow zone any longer than necessary. Then, once I'm ready to go, I pause for a moment and take a deep breath. As soon as I lift the lid on a petri dish or jar, I'm in the red zone. If some mold spores are going to sneak in, this is their moment. I take slow, even breaths through my nose, and I'm constantly aware of the position of my hands. I get in, do the work, and I get out as quickly as I can. Now, this is a crucial moment in the life of the fungus, but it's really not the end of the world if you slip up, fumble, or something goes wrong. Be excited about it, don't be stressed out. Not every agar wedge is destined to become a monumental fungus. It's not about walking a tightrope, it's just about being present. Having said all of this, I also want to emphasize that sterile culture work can be quite forgiving. Just because something was exposed to a contamination risk doesn't mean that it will contaminate. On the other hand, no matter how careful and meticulous you are, you're always going to have problems from time to time. Think of it like a batting average. Even the best batters in the major league still only hit 3 in 10. In the commercial mushroom cultivation industry, a 90% success rate is considered very good. For a DIYer, 70% is completely acceptable, and if you're not even working with a laminar flow hood, you should be happy with 5 out of 10. That said, of course, we want to shoot for 99% or better, and that's definitely possible when you follow the techniques that I'm outlining here. But my point is that one of the most important factors in mushroom cultivation isn't your equipment, it isn't having all the right techniques, it's having a good attitude. More so than almost any other hobby or trade, mushroom cultivation requires patience, persistence, a willingness to experiment, take risks, and fail. Failure is a necessary and inevitable part of the learning process. I trust that you wouldn't even be here if you weren't willing to try something new and step out of your comfort zone. In my opinion, the most valuable result that we get from working with the fungus is not the harvest, it's the wisdom that we gain from drawing close and heeding the lessons that these remarkable organisms have to teach us about life, about our world, and about ourselves. Stay curious, investigate. Remember that everything is an experiment and that all experiments have results, even if they're not the results that we're looking for. We are cultivators, yes, and we want all of our babies to grow and thrive. But we're also scientists, and remember that a big part of science is redundancy. Don't just grow one variety, grow several. Don't just try one technique, try a few and see what you like best. If half of your experiments fail, just do twice as many. If you start out expecting it to always be fast, easy, and profitable, you're going to be disappointed. But if you approach with an appreciation for the vast complexity of life, every success will be a cause for celebration. I find that many newcomers to mushroom cultivation, myself included, have some early successes and think, wow, this is easy. When we're doing something for the first time, we're overly cautious because we're so worried about doing it wrong. It's when we get cocky that we get sloppy. The real test comes when problems arise, over and over and over. Mushroom cultivation can be heartbreaking when it doesn't work and you don't know why. There is always a reason, and every problem has a solution. But before you can move on and figure it out, first you have to move past frustration. A lot of times, the best we can do is just start over and try again. If you're looking for some help problem solving your mushroom cultivation process, make sure to stay tuned for my upcoming video about troubleshooting contamination. And if you haven't been there yet, don't worry, you will. So to conclude, and forgive me for being cheesy, if you ask anyone who's found success, be it in business or in love, what's your secret? They'll all tell you the same thing. Don't give up. Sure, hard work has a lot to do with it, and so does luck. But neither of those are going to get you very far if you're not willing to fail and try again.
Yar! Never give up! Never surrender! Come tempest or trichoderma, sail on, my cities!
Okay, finally, we're almost ready to get to the action. But first, we've still got to set the stage. I'll be demonstrating all of this using a laminar flow hood, but just keep in mind that the process is more or less the same if you're just using a working flame. Before anything else happens, I turn on my flow hood and let it run for at least 30 minutes to clean the air in the room and dislodge any particles which may have settled there since the last use. I like to wash up a bit before I begin, scrubbing my hands and forearms with soap and water. Most people advise clean laundry in a shower, but that's a lot to ask of someone like me. We crusty tree lickers have to draw the line somewhere. Next, I sanitize the entire workspace from top to bottom and back to front using a paper towel soaked in 70% isopropyl alcohol. I make sure to get all those little nooks and crannies. While you're doing this, careful not to bump your HEPA filter or blast it with alcohol. It's delicate and oh so precious. Now I'll check and make sure I have everything I need within arm's reach of my workspace, including my alcohol lamp and jar, my implements, paper towels, ISO bottle, a roll of masking tape, and Sharpie for labeling, and I like to always have a bin for dishes and garbage, which I'll take out of the lab as soon as I'm finished. I like to keep all of it on a little cart. As a side note, everything in my lab is on wheels, which makes cleaning a lot easier. Once the workspace is sanitized, I'll also sanitize each and everything that goes into it, including the lamp, any jars, sleeves of petri dishes, and the whole scalpel handle. Next, I'll sanitize my gloves. I encourage frequent and even compulsive glove sanitation. I spray each hand with a firm blast of ISO and rub it all over every part, taking extra care to sanitize my fingertips. I have come to quite enjoy the sensation of alcohol evaporating from my gloved hands, and I find it to be a meditative ritual to bookend each separate task. Not sure what to do next? Spray your hands. Switching species? Spray your hands. Touched your phone? Spray your hands. Not sure if you just sprayed your hands? Spray your hands. When in doubt, spray your hands. Remember, there's a difference between being sanitary and sterile. Before we use it, we need to flame sterilize the scalpel. I want to see the blade get red hot. I also like to really cook it at the beginning of my work session, working the heat of the flame all the way up the blade and spending some time in the area where the blade and the handle meet. Now the scalpel is sterile, but it's way too hot to use, so I'll cool it in the alcohol bath, tilting the jar to get that satisfying hiss as the denatured boils on the hot handle. Now, it's sterile and cool, but it's covered in alcohol, which will damage the mycelium on contact. So I'll flame it off by passing it through the flame to light it, wait a moment for the alcohol to burn, then run it quickly past the flame a couple of times to make sure it's totally dry and there isn't any residue. Once it's gone through this initial treatment, I usually won't be quite so thorough when I re-sterilize it, but I'll still heat the tip red hot, cool it, and then flame it off before each task. I also take a little extra time with this step each time I switch between strains or species. When I'm not using it, I store the scalpel in the alcohol bath, and I take care to set it down gently so I don't bend the tip any faster than necessary. It will inevitably warp and dull from all the heating and cooling, so you will need to replace the blade periodically. At last, we made it. The moment we've all been waiting for. So much preparation for such a quick, simple task. The first thing I'll show you is a basic agar transfer. This is the backbone of sterile culture technique and the most essential skill to practice. Now that everything is sanitized and ready, I'll peel the parafilm off my original plate and set the new ones next to it. Then I'll re-sanitize my hands and re-sterilize the scalpel. Before I open the lid, I like to take my time examining the mycelium and carefully deciding where I want to cut. In general, we want to work from the leading edge. This is where the most active growth occurs, and where we'll find the highest number of hyphal tips, which is where all the magic happens. Our goal is to only select active, healthy, vigorous growth to carry forward into the future of this fungal lineage. If the mycelium is already grown to the edge of the plate, I'll often just cut all the way to the edge to make my wedge. Just like they taught us to hold 2 and 10 o'clock on the steering wheel, I like to position my hands at 4 and 8, downwind of the dish, and then I turn the petri dish to a good angle for cutting rather than moving my hands. Remember the no-fly rule. I always want to try to avoid passing my hands over the open petri dish. With the scalpel in my dominant hand, I hold the lid of the petri dish in the other. I lift it up and back and use it to hold the open petri dish in place. I like to keep 3 points of contact between my fingers and the lid, and 3 points of contact between the lid, the petri dish, and the table. This keeps the plate stable as I cut and also allows me to turn and slide it a bit while I work. I brace the heel of my scalpel hand on the table for maximum stability, and I always start by cutting with the grain of the mycelium before making my cross cuts. I cut all the way down through the agar, gently dragging the scalpel tip on the bottom of the petri dish. Most of the time, the scalpel is sharp enough I can just drag it through the mycelium to make a clean cut. But if it's older, particularly tough, or very delicate mycelium, it can be helpful to use a slicing or sawing motion, especially when cutting across the grain. Once you cut all 4 sides of the wedge, slip the scalpel under a corner and pry the wedge up from the agar. You can skewer the agar wedge by stabbing it from the side with the scalpel tip, then lift it free from the plate. Close the first plate, then lift the lid on the new one and place the wedge in the center. It should stick to the agar and let you easily slide the scalpel out. But if it's stuck on the blade, you can use the inside edge of the petri dish to drag it off enough to be able to reposition it as desired. Now the transfer is complete. I always like to wipe off the scalpel tip with an iso-soaked paper towel to get any lingering bits before returning it to my alcohol bath. Finally, it's time to put those parafilm skills to the test. As I parafilm each of the plates, I take care not to squeeze too tightly or I might squish the agar wedge and get it stuck to the lid. Last, I label the new petri dish with the species name, date, and a culture code. Stay tuned for my upcoming video on managing a mushroom culture library for some tips on how to use these codes to track cell lines. Just for good measure, I also always seal my petri dishes in a Ziploc sandwich bag. This way it's contained if the fungus rejects its captivity and manages to escape. Whenever I do agar transfers, I always like to have redundancy, so I usually make multiple plates at once. I use a wide variety of agar media recipes and collate my stacks of petri dishes so that each plate is different. This way, I not only have a backup if something goes wrong with one of them, but I also have different growth types on the different media to choose from later on. I'll explain all this in much more detail in my upcoming video on making agar media and pouring petri dishes. To quickly transfer several plates at a time, you can just keep the new plates in a stack. Then make parallel cuts and transfer the agar wedges one at a time into their new homes. It's best practice to avoid leaving a petri dish open any longer than necessary. I'll even close the dish just to spin it around rather than turning it with the sterile media exposed. When working with multiple plates, I try to stay in the habit of always closing one before ever opening another. Next up, I'm going to show you how to transfer agar into sterilized grain to make grain spawn. This is a very traditional technique for expanding mushroom cultures, and even though liquid culture makes this technique more or less obsolete in commercial settings, it's very reliable and a great method to practice as you're getting started in your cultivation journey. The process is pretty much the same as a plate-to-plate transfer, but in this case, I usually cut up the whole petri dish into wedges. I loosen the jar lid so I can easily lift it, just like I would with a petri dish, and then transfer the wedges one at a time. Obviously, there are faster ways to do this, but I like to start folks off with this slow, methodical approach because it has the highest chance of success. One petri dish can inoculate several jars. The number of wedges you use will determine how quickly the mycelium will envelop the whole jar. Once the wedges are all in, I screw the lid down tight and parafilm it before gently shaking and rolling the jar to try to evenly distribute the agar wedges throughout the grain. You can use this exact same process to make liquid culture. Go check out my video, How to Make Liquid Culture the Easy Way, for a detailed tutorial on preparing and sterilizing your liquid media. Once you have your sterilized jar, you can just cut a few small wedges of agar and toss them in just like you did with the grain. It only takes a few to make a solid batch, so you can use a single petri dish to make several grain jars and a bit of liquid culture at the same time. Just keep in mind that grain and liquid have different sterilization times, so they'll need to be prepared separately. Once you feel confident with your sterile technique, you can ramp up your production exponentially by using my liquid culture blender tech, which I describe in great detail in my first YouTube video, How to Make Liquid Culture. This is by far the most efficient way to expand fungal biomass for commercial scale mushroom cultivation. Once you have your finished liquid culture, it's always a good idea to verify it using a streak test. For this, you'll need to sanitize and flame sterilize an inoculation loop. Carefully sanitize the outside of the liquid culture jar, remove the parafilm and loosen the lid. Flame off your loop and just dunk it in the liquid. Immediately replace the lid, then drag the loop in an S pattern across a new petri dish. Wipe off the loop, tighten the jar lid, and parafilm the jar in the streaked petri dish. After you incubate it for just a few days, you'll hopefully see clean, uniform, vigorous growth. While you're getting the hang of these processes, it can also be wise to test your culture in a small grain jar before inoculating a huge run.
Okay, so now we've covered all of the main ways to work with a mushroom culture on agar. Next, I want to show you how to get one started in the first place. There are 3 main ways to do this. The first and the easiest is just to get a mushroom culture from someone else. The second is to clone a live mushroom. And the third is to germinate spores.
Obviously, the easiest way to start a new mushroom culture is just to get one from a fellow mycologist. I recommend using a liquid culture syringe. Liquid culture syringes are convenient, affordable, and they keep and travel well. Just a few drops from a syringe is enough to start a new petri dish, so you can cap the rest and save it in the refrigerator for later. Unlike with agar plates, liquid culture syringes last a very long time in cold storage, making it easy to preserve that culture for years to come. You can find a lovingly curated selection of gourmet and medicinal mushroom liquid cultures by donation on my website at fungaia.life. And no one can beat the quality, selection, service, and value offered by our dear friends at truebluegenetics.org. Thanks to True Blue, it has never been so easy to get a solid start in mushroom cultivation, and they carry some of the most unique and exquisite genetics available. I've always been super impressed by this company and everything that they stand for, and I know you will be too. An even more exciting way to collect new fungal specimens is to clone them from the wild. There are few joys as thrilling as cultivating a mushroom that you originally found somewhere out in the world, successfully cloned, and grew all the way from scratch. Cloning is an essential tool for breeding projects, allowing us to select desirable characteristics from mushrooms that we've grown from spore. Also, if you're interested in outdoor mushroom cultivation, cloning is often the best way to get varieties that are already well adapted to your environment. Plus, it's just so dang cool. You can turn one tiny little piece of a mushroom into a lifetime supply of that particular species with just these simple techniques that I'm showing you here. Now, you can clone just about any fungus, but a great way to get some practice is to use some store-bought mushrooms. You'll want to find fleshy gourmet mushrooms like oysters, and it's best to steer clear of industrial agaricus strains like buttons and cremini. For this demonstration, I'll be using some commercially grown lion's mane. Now, the secret to successful cloning is hydrogen peroxide. Just your regular old 3% USP hydrogen peroxide from the pharmacy aisle of your local grocery will do. Tear or cut a thick but manageable chunk of your mushroom and submerge it completely in a jar of your hydrogen peroxide. Hydrogen peroxide has a variety of uses in mushroom cultivation, as it destroys single-celled organisms on contact, but is relatively safe for mycelium. Once it reacts, it leaves no harmful traces behind. It's easiest to clone from the thick, meaty parts of the mushroom. Mushrooms are made of pure mycelium, and they have a great immune defense, so the inside of the mushroom is generally totally sterile. We really only need to worry about cleaning up whatever is lurking on the outside. Get a fresh petri dish ready, and sterilize your scalpel. You may also want to use a pair of forceps for this. Tear the mushroom in half lengthwise following the grain to expose the clean inner flesh. Hold the mushroom so that the exposed flesh is upwind closest to the filter. Use your scalpel to cut across the grain, then slice, pry, or pinch a small piece of the mushroom and try to get it to stay put in the middle of that agar plate. Some folks use antibiotics in their agar plates to ensure successful cloning. I personally like to avoid this practice, though I will on occasion add small proportions of hydrogen peroxide to the agar to achieve a similar purpose. Whenever I'm cloning a mushroom, I like to use a lot of redundancy. I make several new plates, pulling from as many different parts of the mushroom as possible, and at least quickly re-sterilize my scalpel each time to avoid any cross-contamination. Finally, you can parafilm and then tag it and bag it and keep a close eye on the fungus as it explores its new home. Once you have a healthy clone, you can expand it using any of the techniques I've showed you. As a rule, I always try to transfer clones twice to ensure they're clean and free of any contaminants. It's good to transfer earlier than later, capturing the early growth and quickly moving it away from the raw mushroom bits, which could be harboring unwanted stowaways. Don't forget to check out my upcoming video on maintaining a mushroom culture library for more tips about how to preserve your new friends for years to come. Here's another helpful trick. When foraging or harvesting mushrooms, you can dry them and then clone them later. Not only does this allow for more flexible timing, it sometimes even yields better results than cloning the fresh mushrooms. Simply rehydrate a piece of the dried mushroom by submerging it completely in hydrogen peroxide for about 24 hours, and then you can proceed as usual.
All right, so now we've covered all but one very important basic sterile culture technique, and that is working with spores. Spores are a lot like seeds. They have a huge amount of genetic variability. Now, if you take an apple off the shelf at the store and you plant that seed, there's a 1 in 10,000 chance that the tree that grows from it is going to produce the kind of fruit that you want. The odds are a little bit higher with mushrooms, but in general, if you want to create your own designer babies, work with specific phenotypes or morphology, you want to isolate particular characteristics that you're interested in, the only way you're going to be able to effectively do that is by working with spores. When you're first starting out, spores are a little bit less consistent, they're a lot more likely to contaminate, and in general, they work more slowly, and it can be really frustrating for beginners. But once you've mastered those basics and you're ready to move on to more advanced techniques, the work is actually very straightforward and it's incredibly rewarding. I'll show you a few different techniques here for getting spores to germinate, but overall, the most important thing in my opinion is redundancy. The most important thing overall in my opinion is redundancy. The chances are, if you have a lot of different spore pairings, a few of them are going to come out really vigorous, really beautiful, super active, and those are the genetics that you want to preserve, that you want to pass on, that you want to share with your friends, and keep running.
First, you'll need some spores. The best way to get them, in my opinion, is to take spore prints from mushrooms that you grow yourself from proven liquid culture. This way, you can pick the very best mushrooms and begin from the best possible starting point. Another great way to get spores is to connect with other mycologists through mushroom cultivation groups on forums, Reddit, or Discord and offer to make trades. Overall, the DIY mycology community is super generous and supportive, and trading is an important part of the culture. Now, I'll show you a couple of different ways to get your spores from the print onto a petri dish. An inoculation loop is super helpful for this, but a scalpel works too. The simplest method is to flame sterilize your